Hello world, Joshua here. I want to teach you how to solve this LEETCODE problem, number of islands. Now, if you want to do this on your own, I'll include the link to the description. Oh wow, I'm still messing up this intro. I'll include this problem's link in the description below. Now, okay, the problem is given a 2D grid map of ones, which represents lands, and zeros for water. Count the number of islands. An island surrounded by water is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So by the sounds of this, if I were to, oh, and there's an example here too. So it has to be horizontally and vertically. And you can see an example too that if it's diagonally, that doesn't count. They're separate islands. All right. So the first thing that came to my mind is to solve this. Let's just say what constitutes an island. You have to find out what are its neighbors connecting adjacently and horizontally. Oh no, horizontally or vertically. So you do that, you have to explore each part of it until you think you can explore all that land before you can proceed counting another part and see if that whole part is one island as well. Okay, actually let me see if I can simplify that explanation. So like for example right here, if I start right here to explore the land, I'll go all the way right and down. This whole part here is still part of one island. And if I go explore this whole part right here, that's still one whole island. That will be one. But if I were starting from here, only this part right here will be one whole island. And when I iterate through the rest of this ocean, I'll end up in here, and that will be another island. And this one will be its own other island. So what I'm trying to picture right here is that perhaps that maybe I could use... The first thing to come to mind is depth first search. I'm starting at one point and I'm exploring all the branches that are possibly created from, well, it's not, in depth first search it looks like a tree, a graph with nodes. I know it's like a grid, but if you could picture it in a way, you could imagine it as if when you depth first search, you have to check out all the possibilities starting from the part you start at that part of the matrix and explore that part like all the way to the depths, like the deeper you go in the y direction or the x direction, and see how much of it is all a part of one island or not. So I guess it's better if I just start right here to explain it via an example. So let's say I'll do, first I want to start initializing if islands should equal 0, and as I mentioned, well, we have to go and iterate through each section right here into I equals 0. We're going to iterate through each index. I is less than grid.length. We probably should explain what a depth first search is. As I mentioned, yeah, a depth first search is like you start at the initial part of, in this case, the grid, and you go to to the deepest possibilities you can that connect to that one node within the starting point that you begin with. There's another way you could search through this is through a breadth first search. And a breadth first search in this case is that if I start right here at 1, I'll check out all my neighbors, and in those neighbors I'll go and iterate through this like 1, and I'll start iterating through these neighbors right here, 1, 1, 1, and then the neighbors right here. Whereas in depth first search I just go all the way out and I explore based on just going deep venture first without, doing it layer by layer. If you still have questions about that, please comment below. I'm pretty sure there's people who can explain it better than I can. I'm still practicing how to explain stuff better. This is why I actually started my YouTube channel right here. I'm trying to be a better explainer. Okay, so in this sort of what I'm doing right here with these nested for loops is I'm trying to explore each of these grids right here, and you could tell that they're marked by these 1s and 0s by characters. And I could tell that, and I would only notice it if it's in land. So it should be like this. If grid, if I know it's land if I find it to have, oh, it's not 1s and 0s, damn, it's L's and 0s. L's and O's. Is that an L or an O? Dang. Why do they make it characters of 1s and 0s, man? Okay, I'm just going to copy and paste this just to be sure. I don't know if that's an L or a 1. It's definitely a 1. Alright. And what I want to do in there, I start there, I mark it, I know it's one island starting right here, and I explore that land. Now, I do something called a recursive call. here, let me just do this. DFS stands for depth first search, and I want to do a recursive call on 1, the grid, 2, where am I located on that grid, and what will and then once I explore that whole island from starting this node and whatever connected ones are, this is what this depth first search would do. Check what ones are connected to that one right there via its neighbors and neighbors and neighbors and stuff like that. Once I'm done exploring that, I want to return a number of islands. Now let's define that method DFS. It's going to be a void. I don't want it to return anything. And I'm going to look into the grid reference itself, int I, int j, which is the location of where I started off exploring. It's like my location where I'm exploring. Now, one thing about recursive calls, is that they call on each other over and over again. Like if I find I have a neighbor right here, I call the DFS explore here, and I have to call the DF explorer here again and again, because it still has those ones as neighbors. Now you might reach a point when it might be A, outside its boundaries of this matrix, and B, it might be there might be zeros that it's going to be right near water, so you cannot explore that part. And then another condition that you want to note is that once you explore a part of the island, you don't have to re-explore that again. So what I'm trying to say is that when you do a recursive call, it won't go on forever. You'll be making a mistake. You want to make sure that there's a base condition where it should stop. And you can tell from here, like in this case, that as I mentioned, those 3 conditions. 1, I has to be within the grid's constraints. It cannot be going past it. So first, I and j cannot be greater than or equal to the grid's length. And also, something to consider, I has to be, if its I is less than 0, that's a problem. If j is less than 0, that's a problem, because that's not within the constraints of, it means it's going, this direction or that direction of that grid right there. Now, one more thing to consider, if the grid ij is already marked with a 0, you definitely don't want to re-explore that part again. And here you just return. We return because we don't want to explore that part again. We go back to where we left off previously. Now, if there's land in there, like we'll just say I stop right here at 1, there's 3 things you should do. You want to first, you want to mark off the grid as you already explored that area. 2, 0. There you go. Now I want to explore in several different directions of the grid. So first I want to explore below. So if I start here, I want to go look down. Another part I want to explore is, here, I'm going to make a few more. You're going to explore in 4 directions, horizontally and vertically. I plus 1, I minus 1. Oh boy. Here, I want to find a way to make this more standard. It annoys me when things are out of line. A peeve. Okay, now j plus 1 and then j minus 1. So now we explore in 4 directions. Down, up, right, left. There you go. Now, once you're done, you just return. Actually, I don't know if that return is necessary. Well, let me see what happens if I leave that off. I just run code, see if that works. Oh, it works. It was accepted. Let's see if I submit it. Would it be working properly? Hot diggity. I'm glad it worked. Okay, and now some things to keep in mind, I don't know if this is probably obvious for most of you, but for me, it took me a freaking long time to understand why. Like, you might be wondering, okay, this grid is passed into this part right here of the section. I mean, it should be local to this function, right? If you, like, how do you still reference the grid and marking it 0 to the parts that you've already you've already been to, as places already visited. Okay, I mean, you might be wondering, how does this work? I mean, it's only up to this function right here, to this enclosure. Well, actually, we're passing in the reference of the whole grid right here, and we're still passing that reference to that same memory that's stored of marking of those ones and zeros. So just to keep that in mind, you might be thinking maybe that this grid should be like, this car grid should be right here. Like, you should make it global so that this method could access that part of memory as well. But when you pass a reference, it should be fine when you make changes to it. So anyways, I'll go over it again. One, I want to initialize it with 0 because we're going to get ready to start counting. Now we start from each part, we go into each part of the grid. And for each section of the grid, I do a DFS, which is a depth first search. And when I'm doing this depth first search, or depth first, I'm traversing through this, almost like a series of nodes right here of like its neighbors that are connected to the part where it first started, via A, horizontally, or B, vertically. And then it will stop if it reaches the boundaries of 1. It already visited that area, like it's water, or it's already been visited. 2, if it goes out of bounds of that grid. And you can see I went up, down, left, right. And this is when I mark it when it already visited that spot. So if I were to say, what is the time complexity and space complexity? So the space complexity doesn't bring in additional space. So this must be of O of 1, I suppose. Oh wow, it doesn't sound right for some reason. Let me think about that. I think it's about right. It's about constant time, constant space. It doesn't change much. Now, if I were to go and say what's the time complexity, if I had to go through this whole grid one at a time, it's going to be O of m times n, where m is how many nodes are in each row, and n is the number of rows within the grid. Okay, so that'll be OM times n, and then since I'll be doing a depth first search right here, worst case scenario will be OM times n plus OM times n. So it'll be about worst case scenario, O of 2 times m times n. And yeah, that'll be it. If you have any questions, let me know. If you like and subscribe. Oh, first, also, I want to emphasize this because I'm trying to become a better explainer, and there might be some parts where I probably should put better explanations about. Let me know in the comments. I'll try my best to clarify, and I will also, maybe in the future, I'll take this video down and replace it with a better updated explanation. So anyways, thank you for watching, and like and subscribe, and if you do, I'm going to take you to the Bahamas, the Bahama Islands, and you could go there yourself and count how many islands are in the Bahama Islands. Just count in the 2D grid of 1s and 0s and all that stuff. But just kidding, guys. Have a good day. See ya.